Hello, this is Matt Darkangelo with Aztec Technologies, and today I'll be giving you an overview of the upgrades performed at the Textron Niagara Falls Environmental Remediation Project site. These upgrades focused on centralization of controls and enhancements in sensor technology. The site is located at the intersection of Walmore Road and Niagara Falls Boulevard, adjacent to the Niagara Falls Airport. The treatment building, which is designed for the recovery and treatment of groundwater impacted with chlorinated solvents, is located in this approximately 8,000 square foot building where the little white hand is here. The wells are distributed throughout the site, some of which are actually visible from this aerial photograph. The little white dots here are those wells. As we zoom in, you can see them up a little better, and you can actually see the trenching which connects the wells and leads back to the remediation building, through which the piping, control wiring, and electrical power is run. The photograph of the treatment building located on the property. And here's a close-up of the exterior of one of those well vaults. The fact that these wells are dispersed throughout the site and in vaults leads to one of the challenges that necessitated the upgrades. Many of the controls were located within these vaults, which required confined space entry to access and perform maintenance on. With the controls removed from these locations and pulled back into the control room in the main remediation building, is able to increase reliability of data and transmission, as well as limiting the time and cost of confined space entries. Here's a photo of the current interior of the treatment system with the large air strippers shown here. Aztec's role in the project consisted of constructing control panels, running control wiring to the locations to new sensors located in the wells, as well as some new sensors located within the process equipment itself. Now here's a photograph of the main control panel that Aztec constructed after it was installed and operational. As you can see, local readout on the PLC within the cabinet, as well as several lights and manual shutoffs for alarm modes and discrete inputs and outputs to the exterior of the panel. Now here's the slave panel, which is reporting back to the master overall control panel. This panel here is responsible for controlling the pumps, as well as taking readouts from the pressure transducers located within the wells. Now let's log on to the site and see real-time what's occurring. The first step in this process is to open the site group file. Okay, as you can see here, we're not currently logged in, as all the readouts are static and the inputs and outputs are grayed out. Dialing the site remotely. One of the other benefits of bringing all the controls back to a centralized location is we're able to eliminate the need for the radio frequency transmission back to the site. We did this by actually pulling new control system wires from the main building all the way back to each individual well location. And now we are connected. We're authenticating into the system. And now we have a real-time readout of what's going on. We're currently discharging at just under 18 gallons per minute, and we have about 10.6 inches of water column through the air stripper. Pressure through the bag filters, 12.7 pounds per square inch, which is fairly reasonable, and there's plenty of room to go. One of the benefits of this system is you can do simple reports on totalizing our flow. Since this system has been installed approximately a week and a half ago, we've pumped and treated almost 300,000 gallons of water. The system has data logging capabilities in which we can go look at various inputs, discrete or analog, and then download that data and import into a spreadsheet for further analysis. Now, because the site actually has two controllers, and one is master and the slave, we'll switch over on the network and look at the second controller, which is showing our readouts and the groundwater levels in each of the pumping wells. As you can see here, the wells in which we're pumping more heavily are actually depressing the groundwater to a greater depth in their local area. The readouts here, as you can see here, are in feet above mean sea level. Well 13, pumping the highest, is achieving the most groundwater depression. Now, the reason the lower wells are throttled back is because they have a more significant amount of chlorinated solvent impacts, and therefore trying to blend the influent through the air stripper in order to be able to pump at the maximum rate. In addition to being able to view trend and totalizer information on the system effluent, we can look at that on an individual well-by-well basis. Each well also has local alarm controls, which will allow various processes to be instituted if we go outside of an alarm condition. As you can see, well number 11 is capped at a 21.1 gallon per minute flow rate. However, well 13 is allowed to pump up to 30 gallons per minute. Also have the capability of setting alarm levels to the water level in the well to make sure that the well is not completely dewatered, therefore causing the pump to risk a potential of burnout. Overall, I think you can see that the centralization of controls and access to reliable, real-time information is a great improvement at this site. I would like to thank you for taking the time to view this demonstration and project overview CD today. If you'd like any additional information on this project, or any information on how Aztec Technologies can help you with upgrades or construction of control panels, systems, or complete environmental remediation systems, please contact us at 518-885-5383. Thank you, and have a great day.